Hello, myself Pratnesh Maurya. I'm working on hash pointer and Merkle tree in blockchain technology and cryptocurrency. So let's talk about pointers. Pointers are objects in programming which store the address of another variable. It can be used in linked list. Linked list is a linear data structure which contain data which is linked to next pointer via pointer variable, which is pointing to address of next node, and hence its connection is made. Here we can see that in image there are head pointers and there are numbers of nodes, record 1, record 2, up to record n. Here you can see that there is a data field of data and pointer which store the address of its next pointer. For example, here record 1 data is stored in head. Record 2 address is stored in record 1 through a pointer. So let's talk about hash pointer. Hash pointer is a special pointer where we can give information as well as cryptographic hash function of the informations are stored. If we have hash pointer, we can verify that our data. We can get back our information. So with the help of hash pointer, we can do many things. For example, we can build data structures, retrieve our information back. We can verify data whether it is changed or not changed. In blockchain, a series of block is linked with the help of hash pointer, and it has data as well as hash pointer to the previous blocks in the list. Apart from this, it has data, hash pointers, and cryptographic values. Benefits: value of the previous blocks. It has digest of that value that allow us to verify that the value has not changed. It has an property of temper evident, which is an immutable property because of hash pointer. For example, let's you have any adversary that wants to harm you. They can change some data of any blocks. Let's say let's escape. Since the data has been changed, the block in the block is k plus 1, which is the hash of the entire block k, is not going to match due to the property of collision resistance. Here we have hash pointer, sorry, linked list, which has many blocks. They are connected. They form total blockchain. In blockchain, we have first block called Genesis block. Apart apart of this, there are block 1, block 2, block 3, and pointers of the last blocks. So in blockchain, we can see that pointers hash of the block and data. First in block, say let's say an example block 1, it pointer of a block 0 and hash of block 0, and it has data of its own. Similarly for block 2, pointer of block 1 and hash of block 1 and its data. In a binary tree, with if has any hash pointer, then it is a Merkle tree. A Merkle tree is a simple mathematical method for confirming the fact of a Merkle tree. They are used in cryptocurrency to ensure that data blocks sent through peer-to-peer network as whole, unchanged, and unaltered. They are play a very crucial role in computation record to keep cryptocurrencies like Bitcoin and either running. The parent node are in turn grouped in pairs, and there has towards one level of the tree. This continue all up the way the tree until we reach the root of the node. Cryptographic hash function maps any type of arbitrary data of any length to a fixed size output. It is commonly used in cryptography since it uses cryptographic functions. They are efficient and well known for their property. And we know that they are irreversible, and it's a one-way function that only mean to work in one direction. Some of hash family availables are message MD, which is message direct. It's secure function. Um, it has properties like deterministic, pre-image resistance, computationally efficient, and cannot be reverse engineered, and collision resistance. Working of Merkle tree. Here we can see that it's the Merkle tree with their data, their leaf nodes, and their root nodes. There are some features of like temper evident. It's just like blockchain. We remember that hash pointer in the root. Then we can transverse down to any leaf data block to check if node is tempered or not tempered. Proof of membership. to verify your data, we only need to transverse the path from the top of the leaf where the data is. The time complexity of that is order of log n, which is much more efficient compared with order of log on a linked list blockchain. Tamper evident log. So let's say any attacker want to tamper with one block of chain. Let's say here in block one, the attacker changed the content of block one because of collision free property of the hash function. He is not able to find another data which has the same hash with older one. So the hash of the pointer this is modified is also changed. To avoid noticing the inconsistency, he also need to change the hash pointer of block in the next block, which is block two. Now the content of block two is changed. So to make the story consistent, he also try to change another. Similar this way, he will try to change. But at the end, we have root of the Merkle tree where he can't alter the head pointer. This way we can verify that our temper is happen or not happens. Let's hear example how they are working. First, they have four hashes, hash A, hash B, and hash C. Each has transaction ID with A, B, C, and D. So the hashes are paired together, resulting in hash AB and hash CD. After that, the Merkle root is formed by combining two hashes of hash AB and hash CD to form hash of A, B, C, D. In reality, a Merkle tree is much more complicated with a transaction ID of 64 character bit long. Still, this is example. So let's talk about the benefits of Merkle tree in blockchain. First of all, it validates the data integrity, which can be used to validate the data integrity effectively. Second, it take a little disk space compared to other data structure. The Merkle tree take up very little disk space. Third property is that tiny information across network. Merkle tree can be broken down into small pieces of data for verification. And last one is data format is efficient and verifying data integrity takes only about few moments. So why it is essential to blockchain? So Merkle tree is essential because let's think about without the Merkle tree in blockchain. To get sense of how vital they are, blockchain technology. Let's have one of Bitcoin because it uses Merkle tree essential for the cryptocurrency and it is easier to grab. Uh, Consider scenario if a Bitcoin does not include Merkle tree. So every node on the network would have to retain complete copy of every single Bitcoin transaction ever had. So if you imagine how much big data it can be happen. So for authentication request on Bitcoin would require an enormous amount of data to be transferred over the network. Therefore, you will need to validate the data of your own. To confirm there are no modifications have been done, a computer used for validation would might be require a lot of computing power compared to other ledgers. So solution of these issues are that providing the giving tiny amount of information across the network is that required for transaction to be valid. Furthermore, it enable to demonstrate both ledger verification are identical in terms of nominal computer power and network bandwidth. Uh, Interplanetary file system, a peer-to-peer distributed protocol, is another suitable implementation. It is an allow computer to join and uses centralized file system. It's a part of the technique that generate variable certificate transparency log. Like Amazon DynamoDB and Apache Cassandra use its data replication process. So Merkle tree is an essential fundamental of blockchain technology. It enabling its growth in the IT world, simplifications of designing and decipher the global craze surrounding the blockchain, Bitcoin, cryptocurrencies, and many technologies like Merkle tree. So here we can see that Merkle tree is breaking the tiny formation into many parts. Let's here example is block one and block two for their simplification purpose. Thank you. That's all about for this.